Hello class, these are our notes for section 210 in Algebra 2, Multiplicity of Factors. So first we're looking at the behavior of zeros of polynomials. So given a polynomial in factored form, the factors determine the x-intercepts of the polynomial. Let's get my pen working here. So x-intercepts of the polynomial, and therefore where the graph of the polynomial intersects the horizontal axis. So horizontal, we really mean x-axis. The behavior of the graph directly around the x-intercepts is determined by the degree or multiplicity of the factor. The multiplicity of the factor is the number of times the factor is present in the polynomial. So let's think about, first of all, if we have a factor raised to the first power. So this is just like what a line does, right? We could think about linear is what I could think about, which is a line. And when we have a linear equation and we have a straight line, behavior is it just crosses. And so here's my x-axis and here is my graph just crossing it. Okay? So if I think about what happens when I have something that's even, so like think quadratic pattern, it's going to bounce. And so I could think about how if I have something like y equal the quantity x minus 2 squared, right? We know the way that graph would always work is it would go and it would hit the x-axis and it would come right back up. And I don't know if it's really good for you to think this. Maybe we should erase that. Maybe we should just look at multiplicity and not get the two confused, because quadratics don't always bounce like that. The next one, if it's third power and we're looking at again an odd, it's going to cross but flatten. And I mean, the way I'm thinking about this though is like a cubic function. If I think about y equals x cubed looks something like this. And that's what we're looking at for this third power. It's going to cross, but it's going to do this weird like flattening thing as it's crossing. So it's going to go something like that shape. All right, so we're going to fill in some information here and we're going to go ahead and do some graphing. So when I'm looking at my x-intercepts, I want to think in terms of x-intercepts because I'm looking at a graph. I have an x-intercept. Remember, we're changing our sign at -3, 0. We've got one at 4, 0. We've got one at 1, 0. And so at each of those intercepts, I want to think about what's going on with my graph, right? So what I'm going to be doing is I'm going to be thinking about how my x plus 3, well, that's to the first power. So I'm going to cross at x equals -3. So let me go ahead and write the word cross below that one. This is my multiplicity / behavior. At 4, 0, it's going to cross as well. And then at 1, 0, that's the one that's squared, so that's where it's going to bounce. So that's what I'm listing for multiplicity behavior. And I like to do that underneath each of those intercepts. So as I'm tracing the graph, I'm kind of thinking about what's going on at each of those points. The other thing that we need to come up with here is our y-intercept. So for our y-intercept, remember we're just looking at the constants. In each of those, let's go to highlighter here. We're thinking about like this 3 times the -4 times the -1 squared. We're looking at multiplying all of those together. So 3 times 4 times -1 squared. Oh, it's a -4. That's going to be a -12. So my y-intercept is 0, -12. My leading term, I don't really need the leading term. Really what I just need is the degree and the sign. But my leading term here is x times this x is being squared. So x times x squared, which is x to the fourth power, and it's positive. There's no number in front, should be something like this. So I know both of these are going to go to infinity. All right, so let's go ahead and let's put all this together. So we're going to graph our points. So -3, 0, 4, 0, 1, 0. I know because of the shape, I want to start up here And so I'm going to start up here. Oh, I need to put in my y-intercept also. Y-intercept is negative 12. I'm just going to put a point down here and say, hey, that's negative 12. So I'm going to cross at the negative 3. And then I have to come back up through this point. And I don't know how far down to go, and that's okay. But I come back through this point, and it's going to bounce at 1. And I don't know how far down to go again, and that's fine. And then it's going to come back up, and it's going to cross through 4. So our graph is going to look something like this. And again, we don't know these peaks and valleys, exactly how far or low they go, but we just do the best we can. It could be that this one goes like straight through the 12 and comes up. It could go lower than the 12. We just don't really know. So I just try to connect it with a smooth curve and do the best I can. And I like putting those little question marks. That's not my idea. That comes from somebody else. But I really think that's pretty cool to show that, hey, we're not quite sure, but here is a guess. We're just after the graph shape, right? That's what we're really worried about. So on the next one, let's do the same thing. Let's go through and let's find all of our x-intercepts. So I'm going to cross this out because we're not doing zeros, we're doing x-intercepts. So my first x-intercept is negative 3, 0, and then we have 4, 0, and then we have 1, 0. So at negative 3, 0, that one's to the third power. So it's going to cross and kind of flatten out. At the 4, 0, we're going to cross. At the 1, 0, we're going to cross. Let's go ahead and put those points in our graph. And then the next thing I want to do is find the y-intercept. So remember, for y-intercept, we're multiplying 3 to the third power, and we're multiplying a negative 4 and a negative 1. So let's see, 3 to the third power times negative 4 times negative 1, so that's going to be positive. 27 times 4 is 108, so 0, 108. So way off the scale. I mean, I'm going to put it up here, right? It's still just 108 though. We just do the best we can. Our leading term would be the x cubed times the x times another x. So that's going to be x to the 5th power, and that kind of shows us our shape. It could be possibly like this. It could be like this. It could be just like this, right? It's not going to have any more than those 1, 2, 3, 4 turning points. It's going to start low, go high. All right, so it starts at negative infinity, so it starts low, it's going high, goes to positive infinity. So let's go ahead and do the best we can. So when we connect, we know it's going to cross but kind of flatten at the negative 3. So I'm going to make it look like that. And it probably should have flattened out a little bit more. Maybe I'll fix that. These are not going to be perfect, okay? We're just doing the best we can with the information we have. That looks a little bit better. And then we know we're going to go up to the 108, and it could go higher than that, but we don't know. So I'm not really sure how high to make my graph go. And then I want to come back down, and I'm going to cross at the 1. I don't know how low to make it go. So again, I'm just trying to make some kind of a smooth curve here. And then it's going to come back up through 4. So this one was kind of an interesting shape. Again, don't know how low that one goes. Don't know how high that peak goes over there. All right, I'm going to have you guys try this one on your own in class. So you're welcome to try this on your own. It's tricky. There's a negative. Negative's going to flip stuff upside down. So why don't you go ahead and pause the video, try it, and then you can see what I'm doing. So we're starting out by finding x-intercepts. Our x-intercepts are going to be 0, 0, negative 2, 0, and 5 halves, 0. Remember, 5 halves is just 2.5. And we're going to cross at the 0, 0. We're going to bounce at the negative 2. We're going to cross at the 5 halves. My y-intercept I would get by multiplying the negative 2, the 2 squared, and the negative 5. So that's going to be 10 times 4. Oh, wait, we have that x right there. That 0 that's multiplying by everything. So negative 2 times 0. I almost did it wrong, didn't I? So 0, 0, which I already knew, right? I had it right up above. And I think that's what you guys are doing wrong too in class, right? You're looking at that number. You're not thinking about like, oh, but if I put a 0 in for this x, everything's 0. So we've got to be really careful. Leading term is going to be our negative 2x times, let's see, an x squared times a 2x. So that's going to be negative 4x to the fourth power. So something like this, like an upside down W, so an M. And so both of my ends of my graph are going to be negative infinity. Let's go ahead and plot everything. So we got 0, 0, negative 2, 0, 5 halves would be 2.5. So we're going to come from down here, we're going and bouncing at the negative 2, and then crossing at the 1, and then crossing again at the 5 halves. So again, I don't know about these valleys and peaks, how high to make them. So we just kind of do the best we can. And that looks great. All right, so please, if you've got questions, make sure you're asking in class. We're just kind of furthering our study of graphing right now, and the multiplicity is really the new piece today, right? Before we knew our intercepts, we knew our end behavior, and now we're kind of putting it all together. We're adding in this multiplicity piece so we can graph the whole thing. As always, if you need help, please make sure you ask.